Hi everyone, I hope everyone is doing well and great. We're following from an idea of sketching a curve. We probably know how to sketch a cubic function now, and we will now, given a curve, attempt to find the equation, right? So we have about 5 cases that we can look at. These cases should give us a sort of like a broader perspective of how these questions could be asked, and how one should approach them, right? So we have case number one, or one situation, case number one, where you could be asked to find f of x, where f of x is a, x minus x1, x minus x2, x minus x3. If you have done functions, that's x3, guys. Let me probably just fix it. This is x3, right? If you have done a bit of just trying to get my screen properly here. Okay, not winning. If you have done a bit of a quadratic equation, you should be familiar with this form in a quadratic form. However, here in this first case, you are required to find that, but you're also given that your a is plus minus 1. So your a is between 1 or minus. So the point is that you're supposed to look at the curve and decide which one is it. Is it plus or is it minus? So you're using the curve. So it's not like it's just given to you. There are times where it could be given, but let's assume that you're using the curve to decide. So the curve, my drawings are not into scale. You probably know by now. I'll try my best, but yeah, they are not into scale. Let's take this guy over here. Okay, I tried there. Call this guy -3, call this one 1, and call this one 3, right? Call that function f of x, and we're supposed to find the equation, right? Maybe I didn't make this very clear earlier on, right? Let me just try to make this clear. Try to make it quite clear. Now I don't have the space to make it clear. I will try my best. Let's see what I can do. I can try to pull that down. Yes. So before, I know we've looked briefly now at case 1, but before we go into depth, I want us to note that here we are attempting to determine the value of A, B, C, and D, of A, B, C, and D. In the equation, f of x is equal to ax cubed plus bx squared plus cx plus d. So that's the attempt. That's what we're trying to do, right? Okay. Okay, let's go. Now, these are solutions. What we have here, they are solutions. If you want to imagine them as factors, you have x is equal to -3, you have x is equal to 1, and you have x is equal to 3. If you want to imagine them as factors, you can imagine them this way: x plus 3, and x plus, that would be -1, and x minus 3. You can imagine them that way, but you can see that I wrote in I wrote those factors in gray. Those are all the, not necessarily all the factors, my apologies. A is a factor on its own. But those are kind of the factors of the quadratic. So now let's probably just take a look at how we would go about this. You know, one could use factors if they want. I will actually finish what I've started here after I've done this. Okay, let's have a go here. So this could be, we know that we're trying to find f of x is equal to ax cubed plus bx squared plus cx plus d. That's what we're trying to find. We also know that this can be written in the form of x minus x1, x minus x2, and x minus x3. My apologies for that jump. That would be 3 over there. Yes. Okay. Now, remember this first case. This first case assumes that a is either 1 or negative 1, right? So this first case assumes that a is either 1 or negative 1. Based on the graph, what would we say a is? So we would say that a is 1. Why? Because this is an increasing function. For an increasing function, a is 1. You nicely see this idea of an increasing function when you look at the parent graph, right? So a parent graph would look like this. A parent graph of a cubic function would look like this. And you can see here, as the values of x increases, the values of y increases. So that's the definition of an increasing function. But as soon as you start getting like the bump and all those, it becomes very vague, because the function is increasing somewhere and decreasing somewhere. But a is increasing. Okay. So we can just go ahead and say our a is equal to 1. You know, justify everything you write. It's an increasing function. You know, you saw that from the graph, and going down you can then say this is 1, and you'll be left with x1 and x minus 2 and x minus x3, like that. Okay, cool. And so therefore what you would then have is to say, now what is my x1, what is my x2, what is my x3? You know, x1, x2, x3, those are your roots, right? Oh, sorry. Just go back. Yes, this and that, you know, those are your roots, right? They are your roots, your x-intercepts, right? So you can say now your x1 is equal to minus 3, and your x2 is equal to minus, oh sorry, your x2 is just 1, and your x3 it's equal to 3. Now you just have to go and substitute them. You substitute them exactly as they are, right? You substitute them exactly as they are. So this is going to be x minus minus 3. Hope I don't run out of space on this one. And then this would be x minus 1, and this would be x minus 3. You know, you substitute them as they are. So going down, you will then have f of x is equal to 1x plus 3 and x minus 1 and x minus 3. Now, if you multiply all that expression out, if you do multiply all that expression out, you will get x cubed minus x squared minus 9x plus 9, which means that your a is equal to 1, as we earlier found, your b is negative 1, and your c is negative 9, and your d is equal to 9. So your task here in this class is just to multiply that out and verify my answer. That's it from me, guys.